Hey friends, welcome back. So this is the project one on supervised learning, right? So here the main domain or the main object of this project is on e-commerce. So what we'll do is we will predict the price of certain product with the help of linear regression, right? So this is purely based on linear regression model and which is on an e-commerce data set. So here we have divided as usual this project in parts. So like we have one problem statement, then second, and so on so forth, and with each problem statement we will be solving or getting the insights of this problem statement. The main purpose of dividing these into problem statement just because of to get better understanding, right? Hope this will definitely help you as well. So before wasting time, let's start with the first thing, that is importing the necessary libraries. Again, we import the warnings, right, or to ignore all the warnings. Then we import all the necessary libraries like numpy, pandas, matplot, paylab, right, train test split, and our linear regression, r2 scores for matrix, and of course the font properties for font manager. Then let's load the csv files, right? So basically we have retail.csv, which I'll also provide in the description as well. Just click on that link and get that csv. And the purpose of providing you the csv of every file is because I am sure that you would also be doing the coding simultaneously. Like, just pause the video, write the code by your end, and just run it to get better understanding. So here we import that. Now we are getting the head. So df.head n equals to 5. So this will get the head of top 5 rows, right? So you can see that what the data is containing: the order id, order id item, order item id, the product id, seller id, shipping limit date, price, right, and other attributes like freight value, payment sequential, payment type, payment installment, and payment value. So the third step that we are doing is checking the information of the data frame. So just clicking the df.info function, running it, and you can see that it will return all the information regarding our data frame, like the non-null values are there, the data type of all the attributes, right? The fourth step is telling that check the shape of the data frame. Now check if there are any missing value in any column of the data set. So again, to check the shape, we normally have the df.shape method, right, or the attribute. So it will return the shape, and here you can see that we are printing star 20 times. So normally you can do that, the string multiplied by 20, so it will definitely return the 20 times that star. And in third statement we are printing that if there is any null values, so return their count or their sum. So first thing, the shape, you can see that the number of rows and the column. Then we have print the styling, and next we are printing the sum of the is null value. So far there are no null values in our data set, that means it is good to go with. Now checking the statistical summary of the data frame and write your findings. So normally get that we use df.describe, right? So describe return us all the values, but t is here for transpose. Okay, so what it will do is it will return the transpose of each column with every description of these statistical, right? So like order item with count, order id with mean, then price with standard. Okay, so next thing what we'll do is, so there is some insight on it, like how we can understand the data, so that we have written manually here. So the first point is telling that in the price column the mean is greater than the median, right? So where is the price column? So this is the price column, and the mean is greater than the mean is greater than the median, right? That is true, and it indicates the distribution is previously skewed, right? So that means the description was skewed previously. Next thing is in the payment values, that is this is the last column, that mean is greater than the median. Again, mean is our greater than the median. Again, the column that is mean is greater than median, again that indicates the distribution is previously skewed, right? The third thing it is telling that in the payment value, right? So this is the third interquartile range. The 75th percentile values are less than or equal to 156, whereas the max value is 195. So this is the payment value again. So 75th percentile, right, is less than or equal to 156. That is true, right? Whereas the max value, that is 3195. Okay, now it seems like this column has some extreme outliers, right? I hope you got the outliers, that we can visualize them by using box plot. Now the sixth step, that is telling that okay, plot the count plot of the payment type, which payment mode is used the lowest number of time to purchase the product, right? So here we are working on the payment type here. So sns dot count plot that we are getting, and df of payment type. So in the payment type, right, we have four attribute, that is credit card, right, boleto, right, voucher, and debit card. So you can see that credit card has the highest payment, that method is used for purchase, when wallet is at second number, third is voucher, and finally that means a few people use the debit card. Okay, so again debit card is the most less used payment method here. Now do a bivariate analysis between the payment type column and payment installment column, right, payment installment column, and plot a bar plot that represents all the payment type labels of all payment installment, right? Hope you got this statement. So what we will do is we are defining a function that is for visualize payment type installment, and here we will pass the data frame. Now we are setting the font. Okay, so the font properties we are getting from here. Now the font p dot set size, we are using xx small, and the cross tab that of our data frame, that is we are doing cross tab in payment type and payment installment, right? So it will plot it like a bar, and where stacked will be true, you can see here. Now plt dot legend, so we are providing the legend here as a title for performance. So you can see that yeah, this is the title for performance. B box to anchor 0.05.1. okay, this is the anchor that we are defining. Lock, that is upper left, right, and properties again, that is for font p. Okay, and finally we are showing the plt. So here if we pass the df in this function, so you can see that it is plotted as our stacked bar plot, right? You can see here, and this is the performance that is given 0 1 2 3 4 5 6 up to 24, right? So you can see that how nicely the color is distributed. Okay, and the wallet that is used, and the credit card that is used, the debit card that is used, and the voucher that is used. This is basically the payment type, and here you can see the installment, right? So the people that use wallet, the payment type was wallet, and the installment was up to 20,000, and the credit card used for the payment. So you can see that again the payment type and the installment respectively. Now the eighth step is, it is telling that plot a pair plot of all the columns using u as the payment type and share your insights. So again, warning, we have already imported above, so no need to import it again and again. Now we are defining the pair plot. So we want the pair plot, so calling from sns, that is cbound, and u we are passing the payment type. So the pair plot will be based on the payment type that we have. So here you can see that now the payment type, you can see credit card again, wallet, voucher, and debit card, and here you can see that the installment that we have, right? Payment value, payment installment. For payment installment you can see that, for payment value you can see that, then for payment sequential, right? And in payment sequential you can see that most of them use the voucher, right? And the freight value, so you can get the freight value from here. The price is clearly defined here, and the order item id, so of course this is the id column. So finally it looks like none of the feature is separating the data perfectly, right? So you can see that. Next thing, the ninth step is plot a heat map that consists of the correlation between all the columns of the data frame. So here we have to plot a heat map. So again, to get the heat map, right, for correlation we call df.core function, annotate is we are giving true. So here you can see that the order id, price, freight value, payment sequential with respect to order id, price, freight value. So what the observation here we can get is, so you can see that price and payment value have the highest correlation. Again, the price you can see and the payment value, that is 0.5. so the red that you can see is the highest correlation. So here in this bar as well you can check that, right? Again, the price and the payment value 0.5. okay. And as payment sequential column has very less correlation with the target column, right? Payment sequential with target column. So our target, so the payment sequential with our target column, that is price. So you can see that it is minus 0.014, right? So if we have a lot of feature, we can drop this kind of feature here. So let's do the same. So before that, what we will do is do a frequency encoding of the column payment type and store it in a new column named as payment frequency. So basically that is the frequency encoding is nothing but is an encoding technique that takes frequency distribution into account, right? For example, suppose we have a data frame that has L rows, and let's say a column C1 of the same data frame consists of two labels, for instance P and Q. Now if P has occurred m times and Q has occurred n times, then its frequency encoding will be ml, I mean m divided by l, right? And the frequency encoding of the Q will be n divided by l respectively. So here the same we are getting. So we are doing the same thing here. The payment group, that is df.group by payment type size divided by length of df, and now df.payment frequency we get from applying lambda function, right? So df.payment type dot apply lambda x for each payment group. Okay, so if we get df.head, so you might have got the payment frequency here as for every particular payment value or payment type, right? Now model building and evaluation. So again, to build our model, first step is to drop these columns. So basically the order id, order item, product id, seller id, shipping limit date. So we don't need in our analysis these, right? So what we are doing is we are simply calling df.drop function, passing all the column value x is equals to 1. So that means it will delete all the columns, and in place equal to true, that means deletion will be permanent deletion. And then again getting the df.info, you can see now all the id columns have been removed, and again we have the final data that we will proceed with. Second is store the target column, that is price in our case, in the y variable and the rest of the column in the x variable. So always remember we store the target column in y variable, right? So df.price will be in y variable, and df.drop, so that means now we are dropping or removing the price column because we have to store it in x value. So normally we can define it as x equals to df.drop price, right? So it will drop the price but keep other value. So this way we define the target column and our x variable. So new x and new y is nothing but we are applying as matrix here. In y also we are applying as matrix here, right? And new y we are reshaping our final y. So third thing what we will do is we will split our data set into two parts for our to apply a linear regression. So it is telling that okay, just split 70% into train data set and 30% into test data set, and using the random state of 42, right, to seeding the same value or getting no conflict in each time. So X train, X test, Y train, Y test. So we are using train test split here, new X, new Y, that we are providing from here. And test size, this time again we are passing 0.30, that is 30 means the 30% for the test size, right? That means the remaining part will go for the training size. Now the random state we are passing 42 as suggested. And the fourth step, it is asking that train a linear regression model finally and print the R2 score for both the train and test set. So first thing, getting the linear regression in our regression variable, regression dot fit X train and Y train. Y prediction train will be regression dot predict. We are predicting our X train here, we will also predict our X test here, so that will be Y predict train, Y predict test. So the R2 score that we will get for train will based on the Y train and Y prediction train, and R2 score for the test that we will get Y test and Y prediction test. So you can see that the R2 score, this is 30% for train set and 31% for test sets, which is very less, right? So what we can do is, next thing we are showing it as scatter plot. So you can see that we are defining the plot regression, and Y test, Y prediction test that we are taking, right? Residue, a variable normal that we are telling that Y test minus Y prediction test. Okay, this is how we will get the Y value. And plt dot scatter, X value is our same, that is Y test, and Y value is that the rest, the variable rest that we just defined. And plt dot plot, so this is what we are defining, the shape and the color, and that is red. So you can see that in our scatter plot, one line is drawn here, right? You can clearly see that. And what it is telling, that the residual are not randomly distributed along the line, right? You can see that not randomly distributed. So this reflect a linear model is not good option for this model. Okay, we can observe the same from R2 score, correlation matrix, and pair plot as well. So this was all about that. We got the conclusion. Okay, so the linear linear regression model that we have applied for our e-commerce problem, so which is not much sufficient in our case. We can also test with other model as well, right, if you want to, but this was an example. If we go with linear regression, how will be the performance? Okay, so before proceeding that, you should get the final result. Okay, this is good or not for my final my further proceedings. So yeah friends, this was all about this video. We will come up with some other projects, right? Stay tuned. All the best.